What's poppin', dogs? It's Mr. Allen, going to be graphing a quadratic function with a domain restriction and its inverse in this video, and getting a whole bunch of details about both of those functions. But what's with this domain restriction? I've never seen that before. Well, a quadratic function, a parabola as its graph, would not pass the horizontal line test. Therefore, it's not invertible, meaning its inverse is not a function. But if we restrict the domain of that original quadratic, then it can be invertible. Now, what's significant about this right here is this is the x value of our vertex, which would be our axis of symmetry as well. So we're just going to get like the left half of that quadratic, all right? So enough talking. Let's put some points here. Let's get a little picture going here, a nice little graph. I've got x is less than or equal to positive 1. So I'm going to pick 1 right here, and then I'm going to pick some values to the left of 1. Let's go with, how about 0? And then let's go with negative 1. Right? This graph is shifted to the right one. I'm going to pick some values that go to the left because I want to be less than or equal to positive 1. If I plug 1 in, I get 0 squared is 0, minus 4 is negative 4. If I plug 0 in, I get negative 1 squared is 1. 1 minus 4 is negative 3. And then if I plug in negative 1, I get negative 2 squared is positive 4. Negative 2 squared is positive 4. Minus 4 is 0. So we have 1, negative 4, right there. 0, negative 3, and then negative 1, 0. So I have this half of a quadratic, and I'm going to label it as f of x. I always have my kids label their graphs. Make sure you do that. Could lose half points if you don't. So there we go. We got f of x on the graph. That's wonderful, and I can actually fill out all this information about it right now. My domain, x is less than or equal to positive 1. So x less than or equal to positive 1. Or you can write it in an interval notation. It'd be negative infinity to positive 1 with a bracket. Okay, so either of those notations, totally fine. I often do the inequality because it's usually given that way in the problem. How about my range? Well, it's always greater than negative 4. So either I would say y is greater than or equal to negative 4, or you could say negative 4 to positive infinity. Your call, whatever you want to do. All right. Next up, x-intercept. This one works out really nicely. It's at negative 1, 0, and my y-intercept is at 0, negative 3. If I didn't have the graph here and it still asked me for it, I can plug 0 in for x to get my y-intercept. I can set the equation equal to 0 and solve to get my x-intercept. Okay, so you can plug 0 in for the other value, basically. Right? So there's everything on the original. Now I want to graph the inverse. You can actually graph the inverse without even finding the equation. However, I am also going to find the equation in this one because it does ask for it. So let's find the equation, and then we can do all the t-chart fun stuff and graph it and all that, but it'll be nice to have the equation up there. I'm going to switch colors for this one. Let's go with orange, all right? Now, I'll do a bit of the work right over here. We'll have this function here originally written as y equals x minus 1 squared minus 4. But to find my inverse, I need to switch my x and y. So I'll have x equals y minus 1 squared minus 4. And now I'm going to resolve it for y. So I'll add 4 first, right? There's a few steps we got to do here. You got to do them in the right order, as is tradition in the mathematics. So add 4, I'll get x plus 4 equals y minus 1 quantity squared. And now I can square root both sides to get rid of the squared part. And I'm going to rewrite this as y minus 1 equals. And here's the thing. When I solve using a square root, I do get this plus or minus. All right. Which one's it going to be? Because here's the thing is if I had both, I'd get that whole parabola on its side. It won't pass the horizontal line test. It actually comes into play right here. Let me actually jump to a different color real quick. X being less than or equal to positive 1 tells me that it will be the negative version. Since I'm picking the left side of the quadratic, I will pick the bottom side of the radical, if you will. So now I'll have y equals the negative square root of x plus 4. We're going to add 1 outside. That is my final inverse. So negative square root x plus 4 plus 1. All right, cool. And you will notice like certain patterns or certain things that happen all the time. Like this is plus, that's plus, it was minus, right? Those things are going to happen here. But I wouldn't just jump right to it and think like you can place everything correctly, you'll probably screw it up half the time. So best to know how to do all that. And oftentimes we are just also giving you points for your work and showing the process that is part of it. All right. So there we go. We've got our inverse equation. Now let's do the t-chart. And you could pick some points in here and fill out the t-chart, or I could just switch my x and y's. Hey. So I can go -4, -3, and 0. And then 1, 0, -1. And you'll notice that if I plug in -4, that's 0. Square root of 0 is 0. Plus 1 is 1. If I plug in -3, I get the square root of 1, which is 1. But it's negative. -1 plus 1 is 0, and it just all works itself out. So whether you use the equation to graph it or you just swap the x and y's, both ways work. So -4, 1, 2, 3, 4, positive 1. Then I have -3, 0. So right on it. And 0, -1. And now I have this beautiful radical that I will label f inverse of x. That's what the -1 means. That's the inverse. And the other thing you're going to see here, and I'll do this with a straight line. If I were to graph my y equals x diagonal line here, my parent function y equals x, get it lined up. It's decent. This y equals x line, these graphs reflect over it. If I graphed it perfectly, they would have hit right here at that shared spot, which I'm pretty close to that. But I'll just hold on to this, I guess. So they reflect over that diagonal line. Now, it's kind of hard to like visualize the reflection over a diagonal line. But when you graph it wrong, it sticks out like a sore thumb. You're like, something don't look right. Okay, this one looks right. Like you could see the symmetry like over it. It's a little weird, but you could see the symmetry there. Whereas if I graphed the upper part right here, it would not look right. Okay, if I had this one and I did the positive version of it, it'd be up here. It would look all jacked up. It would not look like it reflects over that beautiful y equals x diagonal line right there, a parent function of linear functions. One other thing to state here before we finish this stuff up is we said our x's and y's switched, right? Swap, swap, right? Swapped it there, swapped them here to make our equation. So in other words, you're saying that like the y equals x and the x equals y, or it reflects over y equals x. Oh my goodness, all these connections. Pretty cool, right? All right, I'm going to set this down now, and we're going to finish the domain range x-intercept and y-intercept. Now, what do you think might happen? Domain is normally associated with x values, right? It's the inverse. It's clearly, let's see here, my domain is greater than or equal to -4. Oh my goodness, wasn't that the range, but with a y? So now it's going to be x is greater than or equal to -4. My range is less than or equal to +1. Oh my goodness, my domain was less than or equal to +1. So y is less than or equal to +1. And if you want, you can write this in interval notation, being x is greater than or equal to -4 would be -4 to infinity. And over here, we would have when it's less than +1, less than or equal to +1. So, or it'll be -infinity to +1, include that +1. So these guys straight up switch. Same with that, except for your x and y has to be written appropriately. Now x-intercept. Well, it's crossing it -3, 0. Oh my goodness. Crazy, right? -3, 0. And then my y-intercept, -0, -1. Oh my goodness, that was the x-intercept, but it swapped. Cool, right? Lovely connections here. Okay, there we go. Awesome sauce. Graphing f of x and its inverse, finding the inverse, all the good stuff. Trickiest part right here. People always screw that up or miss that, and they leave it positive when it should have been negative. Definitely something you got to pay attention to, okay? So hopefully that helps. If you guys have any questions, let me know in the comments. Otherwise, have a great day, and thank you for watching.